Hello there, mathematicians. Just going to do a quick little video on sine regressions in the TI-84. You should have your notes in front of you, and your notes should look a little something like this. So we're just going to do this first problem together. I'm going to cut the video off, and then you can go ahead and do the remaining problems with your teammates. All right, so this is a calculator active problem. We can see that there's a table of data at the top of the page. The context tells us that this is representing the number of nighttime hours over a certain length of time. Note here that they're telling us that this is for t values between 1 and 12. All right. Also notice that the sine function is written with our normal, A, B, C, D, but something is not quite the same in that the B, T plus C, the argument of our sine function, is not factored, right? So they're not factoring the B value out of the T and the shift, the way that we have seen previously with our transformations, right? That has to do with the way that the sine regression occurs in the TI-84. For the most part, this is my own personal opinion. I don't think they're going to ask you to do a regression and then ask you about what the phase shift is. They're just going to have you analyze probably the A, B, or D values, or they'll just have you use the equation and you'll evaluate at a given input, some of the other graphing techniques that we've done with the T84. So won't be too worried about factoring the B value out from that C, but just something to note that that function is a little bit different than what we have seen in the past. All right. Another thing to highlight here is this phrase 16 iterations. Um, that does not mean 16 cycles, right? That does not mean that, between our data, we're hitting, 16 different pairs of extrema the whole time. Iterations is just the word that the calculator uses for basically how many times you want to refine the data before the model's done. So we have not done this for previous regressions. It's kind of a thing that we're only going to see in the sine regressions. But that number could be anywhere from 3, which is the default choice for the number of iterations when you just boot up a sine regression, and you can go as high as 16. The trade-off there is kind of like the time that the calculator will take to process all of your data. So if you have fewer iterations, then you will get your regression equation a little more quickly. If you put in more iterations, then you will get your regression equation a little more slowly, but with a little more accuracy. So just kind of your call as to what you want to use. Sometimes the problem will tell you, other times the problem will not. So, you just have to feel it out and use your best judgment. All right. So we have all of this together, and we are looking for the range of nighttime hours predicted by the model. All right. So we're going to need to have our model created, and then we can go ahead and look at the range. I'm going to go ahead and switch my screen here. So I'm going to hop in on my calculator. And so the notes have disappeared, but again, I'm trusting that you have the notes in front of you, or if not, back up and just write down the information that you need. Just take a few notes on the prompt and the data. All right. But as we do with our regressions, I'm going to hop into our list here. So I'm hitting stat, and then I'm going to edit, and then I'm going to put in my inputs and outputs in their separate lists. So L1, the inputs were 1, 3, 4, 6, 7, 8, 11, and 12. And the outputs for the function n were 11.4, 9.7, 8.2, 5.2, 5.0, 6.2, 10.5, and 11.3. All right, so I'm just going to do a quick double check to make sure that all of my data is good, that all the values were entered correctly. I would hate to have a typo, run a regression, and then get the wrong answer. That'd be rough. Okay, data looks good. So now I'm going to move on to that sine regression. So we're going to hit stat. We're going to go over to calc as we do, where all of our regressions hang out. You'll notice that you don't see anywhere in the first 9 options that SIN reg or sine reg. So I'm just going to hit the up arrow to sort of come up through the bottom of the list. And then I'll see on option C that I've got my sine reg right here. So sinusoidal regression. This first field is what we were talking about for iterations. If the problem doesn't tell you how many iterations to do, you might stick with the default 3. You might bump up more if you would like to, but the problem did tell us to use 16, so I'm just going to roll with 16. We have our inputs in L1 and our outputs in L2, which is great. Period is only relevant if you know the period from the prompt, right? So if the problem or the context gives you some indication as to the period, then you definitely want to put the period into this field. But the problem for us is not very specific about what the period is. So I'm just going to leave the period blank. All right. And then I do want to store this regression equation just in case I need it in Y1. Okay. And then I'm going to calculate. So you'll see I did 16 iterations there and I got my regression equation pretty quickly. Maybe if we had more data or if the model was like a little more complicated or the data was a little more dispersed, that would take longer, but I did 16 and I sort of got my equation fairly quickly. So these are all of my constants. For the sake of doing the problem, I'm going to just write down some values here, and then we can come back and sort of explore a little bit about what we could do with, or just verifying our sign regression with our data. But because we were asked for the range of the number of nighttime hours predicted by the model, I'm looking at those A and D values because that's going to help me determine what the range is. So I'm going to write down my A and D values, 3.1175. Remember, just good practice to go to, at least 4 decimal values when you're reporting. And when you're actually doing calculations, maybe even better to write down all the decimals that you've got. All right, so I just recorded my A and my D values. I'm going to hop back to my other screen now. There we go. All right, so I wrote down those A and D values. And as we know, our midline corresponds to the D value. And in a sine wave, the amplitude corresponds to the A value, right? So we might find the range by looking at D plus or minus A, right? Or in this case, I would want 8.2153 plus or minus 3.1175. Right, so my minimum would be 8.2153. I have all the decimals written. I might as well use all the decimals. Minus 3.7503.638. All right, and the minimum that I'm getting there is 5.0978. Again, I'm going to 4 decimal values. And then I am going to pull that entry just by hitting second enter, by the way. If you didn't know that you could just recall your previous line entry, second enter, and you'll get whatever you put in as your previous entry in the calculator. And then I can just go over and then change the negative to a plus, the minus to a plus, and I don't have to type in all the decimals again. I'll show you what I mean in a second because I'm not positive that my calculator screen is showing up on the recording right now, but I'll show you what I mean. All right, so that's the range when I add the A and D values together. All right, so 5.0978, comma 11.3328. All right, let me hop back over to my calculator. I'll show you what I was talking about with that second entry, and then I'll also show you another way to get to the range that is honestly a little quicker, a little maybe a little more intuitive. But I just wanted to give you options. All right, before we do that, let's take a look at that second enter that I was talking about in case you didn't know. So you'll notice I typed in on my first line on the screen the subtraction of the D value minus the A value. And I'm using the exact same numbers to get the D value plus the A value. But so if I wanted to just call back my previous line, I would hit second in that upper left and enter down below. And then that entry just showed up right again in my calculator field. So I could come over here. I could change that to be a minus. I could change that to multiplication. I could change that to a power. Well, maybe not then. Nah, never mind. But you can do whatever you want. And now I lost my operator, but I'll insert. So second delete for insert, I'll insert a negative there, right? And now I've got my minimum again. So second entry, sometimes useful. Let's take a look though at what I could do to not have to work with, recording all the decimals and typing all of those in. I'm just gonna zoom 6 my graph and see what's up. Cool, I got my graph. I'd like that window to be a little higher just to see the top of the graph. Let's go 15. Based on the data, I think that's pretty fair. So I'm seeing the sine curve. And if we were talking about finding the range of the function, which is what the prompt called for, another option besides taking d plus or minus a is that we could have graphed the function because we performed our sinusoidal regression and then just found, the maximum and minimum y values. So I'm going to find a minimum here, doing second trace, left bound, right bound. And my minimum there is 5.0978, which is what we got the other way, right? And if I go for a maximum, I'm going to find my maximum y value. So left bound, right bound, and there's that 11.3328, which matches up with the other method as well. All right. So just a quick little video on your sinusoidal regressions, how to calculate them, what to do with them. I think you are empowered to go ahead and finish the rest of the notes. So I will see you next time. Thanks for watching.